Thank you, everyone, and welcome back. Today, our session is on mathematics and its interdisciplinary implications, especially theological implications, spiritual and religious nuances of the breakthrough developments in mathematics. And we have a very rare and unique talent in this field in the person of Dr. Binoy. He is our regular faculty. His sessions were much appreciated by our former cohorts as well. Yet another area of his scholarship is Gödel's theorem, which is mathematically and philosophically, epistemically, perhaps the most challenging mathematical development. Those are the areas of his expertise and scholarship. And he is a visiting faculty at Boston University in the US. And he has authored a number of books and has presented papers in several international forums. And we are really, and more than that, he is a regular faculty of our science religion program, as well as my colleague in science religion activities since the last 2 decades or more. So it is indeed an honor to make use of your genius, Binoy. Welcome to the GMU session. Over to you, Binoy.
Welcome to this presentation on mathematics, manifesting the mystery of God. See, very often people do not like mathematics as a discipline. Mostly, this is my experience. And at times they all the more hate those who teach mathematics or those who are talking about mathematics. Well, this is an approach. This is an interdisciplinary approach. But metaphorically, we can draw a lot of parallels, even when we talk about the very concept of God. We have God, eternal, omniscient, omnipotent. Or at times we talk about a rational God. Likewise, metaphorically, mathematics is, some people believed, still believe, it's eternal. It's omnipotent. It's definitely irrational. So even from a common parlance, we can definitely draw a parallel to the concept of God. And traditionally, we know that the fathers of the church or the theologians made use of philosophy as an effective tool in explaining the mysteries of God. And today, we make use of sciences, the disciplines, various disciplines in sciences, including mathematical sciences, to talk about God. And my proposal is this: mathematics, at times more than traditional philosophy, contemporary mathematics can enlighten our theological mysteries. So this presentation is an attempt to interpret the concept of God from a mathematical perspective. That's why I have phrased the title as Mathematics, Manifesting the Mystery of God. To begin with, if we ask the question, what is mathematics? We will be dealing with it in detail, the following slides. But to put it in a nutshell, mathematics is an abstract science that deals with abstract concepts like lines or shapes or other mathematical entities. And drawing a parallel again, the concept of God is, for us, it's in a way, conceptually, it is abstract. So, dear friends, we begin with this, or against this background, we begin our deliberations. Do you like mathematics if I ask this question? People will be having different perspectives or responses. One may show his head like this, oh, I hate it. And sometimes people may show their hands like this, as I show in the picture. But there are some publications that which talk about mathematics in daily life. It is so much close to, or so much part and parcel of our life. And there are also books on the mathematics of life and death. And there is a book, a couple of books on mathematics of love. So this is very much part and parcel of our life or lives. So you cannot disregard mathematics, even mathematical thinking, mathematical calculations in our daily life. So we are attuned with mathematics knowingly or unknowingly, directly or indirectly, It is so much part and parcel of our life, our thinking pattern, and even worldviews. This is the first premise. And I believe you can see the picture, mathematics and art. Uh, this is a picture by Salvador Dali, the Spanish artist. And the name of the picture, most of you must know, the melting clock. I hope you view this picture, the melting clock. It's in the context of Einstein's theory of relativity and his famous concepts of dilation of time that Dali creatively imagined about a melting clock. Time is melting in consonance with or in resonance with the theory of relativity. So this is the way people imagine creativity, imagination, and the logic of creativity. There is a kind of science and mathematics behind. I'll explain it in detail the next slide. I hope you see this slide, namely Dali Lincoln. Dali Lincoln. This is a famous picture, this portrait. It's if you view this from far away, some 40 meters away, closing your eyes half or half closed eyes, you will see Abraham Lincoln. On a closer scrutiny, you will see good number of hypercubes. Actually, Dali made use of hypercubes. This is known as surrealistic pictures or surrealism in the artistic or aesthetic realm. He made use of hypercubes in order to portray Abraham Lincoln. Even again, if you go closer and on a closer scrutiny, you will see that there is a naked lady standing against the window behind, and she is Dali's own wife, Gaya, and she is looking through this window outside into the lake over there. So once you view this half closed, this is Abraham Lincoln. On a closer scrutiny, reality changes, or you will get other representations. So Dali made use of mathematical cubes known as hypercubes in order to bring in this three-dimensionality and even to the extent of four-dimensionality. Most of his other pictures, you will see the brilliance of this artist making use of hypercubes, that mathematics is being used in art and aesthetics. Actually, there is a famous mathematician in the United States, namely Thomas Banchoff Sr. He is an emeritus professor in Brown University in the United States. He once shared with me that Tom was invited to a hotel in New York. There is he was invited. Again, and those who are attending this session, could you kindly mute your audio so that it will affect our recording? Thomas Banchoff, the renowned mathematician, was invited to a prestigious hotel in New York, and Dali, Salvador Dali, and Thomas Banchoff engaged in a mathematical conversation. They discussed about the possibility of hypercubes bringing fourth dimension, and that's a way he learned mathematics in order to portray pictures of this kind. So that is the brilliance and the genius of Salvador Dali. He is taking us to another realm of dimension using his artistic genius or artistic brilliance. So mathematics is being used in art, and you will also see that this is also used in Dali's own picture, the famous crucifixion. This would also bring in 3 to 4 dimensional experience. When it comes to mathematics and music, it's Pythagoreans, the Greek philosophical schools, who the early school of philosophies, they expressed musical scales in terms of numerical ratios. And they said, this musical sound is a remarkable array of number property. And even with the guitars, arrangements of the lines of the guitars, mathematically arranged. This is the idea what I'm talking about. Music, this is music, the musical form, the rhythm meter, the pitches, everything is actually, you can explain it mathematically with reference to the measurement of time and frequency. This is the idea. Golden ratio, most of you may be familiarized. This is a very interesting feature in mathematics. Golden ratio is based on Fibonacci series. The Italian mathematician Leonardo of Pisa invented a sequence, namely Fibonacci. And Fibonacci, some people say Fibonacci series. And you will see as I display on the screen, 1, 1, starting with the natural number 1, adding is 1 plus 1, 2. The next one will be 2 plus 1, 3. The next number will be 3 plus 2, 5. And the successive pairs will be added to get the, pairs will be added to get the next number. So this is the idea, 1, 1, 2, 3, 5, 8, 13. Now the interesting phenomenon is, if you take the ratio of each successive pair of numbers, it will be approximately 1.618. If you take the ratio 3 by 2, it is 1.6. 5 divided by 3, 1.6. 8 divided by 5, 1.6. So approximately it is 1.618. And later, the Canadian mathematician J. Hambert named this as golden section or phi. And it is observed that this phi is seen everywhere. This is known as the mathematics of the nature. Mathematical ratio is seen everywhere in the arrangements of the petals of the flowers, in the pattern, the leafing patterns of tree, or the width of the tree, or the width of human teeth, even in DNA molecule. And you will see the height of a human person from head to foot, and as well as from his navel up to foot. If you take the ratio accordingly and appropriately, that will be 1.618. And a perfect human person will be having this golden ratio. Look at the face of Mona Lisa, left bottom, and you will see that there is the golden ratio is applied. So even great artists will look for the application of golden ratio for portraying perfect pictures or human form. And this is everywhere in nature. As I said, the arrangements of the petals of the flowers, of leafing patterns, and elsewhere you will see. And this is the idea of golden ratio. The ratio of the sum of the quantities to the larger quantity is equal to the ratio of the larger quantity to the smaller one. And phi will be 1.618. And you will see this ratio, you will see applicable in the hand. When you take the proportion of your upper arm to hand plus forearm will be of the same ratio, phi or phi, you call it, body ratio 1.618. This I have already explained. The human person, a perfect gentleman, will be having the golden ratio 1.618. The same is seen the arrangements of the DNA section. DNAs with 34 angstroms width and 21 angstroms wide width and length. You will see 34 divided by 21 will be 1.618. So this is known as the mathematics of nature, golden ratio. And the quantum world, also you will see, you can found, or we can found, that the frequency of the magnetic spins in the cobalt neobatis in having the ratio 1.618. Well, I repeat, in art and in architecture, the Pyramid of Egypt, or even in the Colosseum, or in the huge engineering marvels, the golden ratio is kept. So this is the mathematics of nature. Golden ratio based on the thought pattern of the Pisa in Italy, and one who invented the Fibonacci series, and later this was been named by Canadian mathematician J. Hambidge. And you see this practically everywhere in the butterflies, the petals of the arrangements of the trees, or the snails arrangement. You will see this golden. Against this background, let me ask the question, what is mathematics? We will be usually classifying this into algebra, arithmetic, geometry, and analysis. You know that algebra is the famous mathematical equations which we have learned in our high school times. A plus b the whole square, a square plus 2a plus b square, which everybody knows. So you use letters for that. Likewise, arithmetic. Arithmetic refers to the arithmetic operations like addition, subtraction, division, see, all these multiplication, arithmetic operations. When you speak about geometry, another classification of mathematics, immediately lines, shapes, triangles, and circles come to mind. And when you talk about analysis, that is real analysis or topological analysis, immediately the limit theory, differentiation, integration, advanced mathematics come to our mind. So when we ask the question, what is mathematics? I repeat, this is an abstract science that deals with abstract concepts or quantities. Pythagoras believed mathematics is the universal principle and number is specifically the primordial arche with which the universe is made. Number brings in universal harmony, he believed. Plato said mathematics is the copies of eternal ideas. They are eternal in essence. And St. Augustine highlighted the meta dimension of mathematics. Galileo and Newton related this with God's language. God's language is mathematics. They affirmed and reaffirmed. Immanuel Kant, he said, mathematics is as real as thought. That's what he said. Well, with this, we move on to the next. What is mathematics? Once again, we can ask because there are different perspectives. There is something called pure mathematics. That is an abstract science. Already mentioned geometry, arithmetic, algebra, and analysis. And when it comes to another classification called applied mathematics, today we make use of computers mathematics in computers, in binary languages, mathematics in biology, in economics, in psychology known as psychometry, economics it is known as econometrics, statistics it is known as biostatistics, or biology it is known as biomathematics. So different disciplines have become interdisciplinary. Accordingly, mathematics has also become applied mathematics, applied to different disciplines in different kinds, different ways. Asking a very simple question, is mathematics part of our life? In fact, I started my conversation with this. We are so much attuned to maths. We use mathematics in our everyday calculations. There are mathematical orientations in our life, in our planning, in our scheduling, calculations. So everything, we are mathematical in nature. And one can also trace the mathematical orientations in our life. So in next 5 years, we want to do this. Next 10 years, the company would attain this much profit. So everything is mathematical, knowingly or unknowingly. We have the mathematical orientations. Whether we are trained in maths or not, mathematical orientations are part of our lives. That is very important. Another philosophical question that we can ask, is mathematics mind-dependent or mind-independent? So we are familiarized with the different schools of philosophy and different schools of thought. They talk about mathematics. The realists are speaking about mathematics or reality is mind-independent. So they believe reality exists outside of the mind, independent of the mind. So we call mathematics is mind-independent. Especially proponents of those schools. And there are also people who are talking about maths mind-dependent. And in philosophical schools, they fall in the category of constructivism. They say that numbers are constructs. Mathematics is a construct Mathematical concepts are the constructs of your mind. So it is mind dependent. But there is another school known as critical realism. They would say this is both. It is both mind dependent and mind independent. If I ask you what is this, I mean, those who can see me, I'm just showing you a finger. Immediately you say that. Some would say it's one, number one. Some say it's a finger. I mean, mathematically it's one. And if I show this, this is two, right? So where does it exist? Is it in your mind, or it exists somewhere outside? If I say there is a tree, there is a tree. There must be a tree. Immediately I am associating mapping to the tree, and counting or numbering is possible through mapping. This is the work of your mind, and the reality exists outside your mind, but it is both mind dependent and mind independent. This debate has been there for long, since the beginning of mathematics or since the beginning of philosophy, whether it is real, whether it is imaginary. This is the question. So a common or a consensus is this: mathematics is both mind dependent and mind independent. And another question, even when we talk about God, we talk about truth. Let us ask, is mathematical truth really true or always true? And I know that you will be having different opinions. Some people would say mathematics has always true. It has to be true. And even when we talk about logic, we know that logically true or logically false. Mathematics is almost like this. In order to understand whether mathematical truth always true, we will have to differentiate this into two categories: logical truth and factual truth. If I say 1 plus 1 is 2, it has to be true, and it will be true, and it has to be always true, because as long as the mathematical logical rules hold, that is always true. And this is known as the rules are, the items are cohering with the rules. And this is known as the coherence theory of truth. This is logically true. Logically true need not be factually true. If I say that it is raining, if it is raining outside, it is true. There is a correspondence with the truth. And this is the famous theory, the correspondence theory of truth. So mathematical truth is logical truth. It is always true. It is logically true. Since it is logically true, it's always true. Because as long as the rules of logic hold, it will be true and it has to be true. This is the idea. But when it comes to factual truth, it is true only if it corresponds with. So it depends on the context. So mathematical truth need not be always factually true, but it is always logically true. So in general, we say that mathematics can never ever make any mistake. It's logically true. That's the idea behind. So this concept of truth is very important when we talk about our idea of God later. I've already mentioned this. I've explained this. This is the idea. In classical logic, truth in classical logic is represented by symbols and their former relationships. So logical truths are necessary and are true in all cases. Logical falsehoods are also false in all cases. Logical truth does not depend on how the world is and how it is not. Similarly, factual truths, I repeat, it depends. It depends on the context. If Earth rotates, if I claim Earth rotates, Earth has to rotate. And since the Earth is rotating, it is true based on our experimental evidences. So that's why factual truths need not be always, mathematical truths need not be always factually true. This we have to understand. Are there mathematics in human relations? See, there's a book called Love and Maths. See, the degree of love relationship is measured. I mean, they have introduced and even an integral equation for that, but there is a fun dimension to it. These are different ways of putting the human relations into the mathematical paradigm. We cannot completely claim that this is It's like asking, can we prove God mathematically? So the gradation or the gravity of the depth of your love can be measured. This is a 2013 book by Edward Frankel. And this is the mathematical equation. They have made use of cos theta and sin theta for this. This is one of the ways of appropriating love in the paradigm of mathematics. Is there fun in mathematics? There is. Suppose I ask you 1 divided by 0, and there is no mathematical entity like that. It is called undefined. You cannot divide a number by 0. But any number, I mean, if you divide 0 by any number, that remains 0. But you cannot divide 1 or 2 or 3 by 0. Likewise, 1 divided by infinity is always treated as 0. And you know that infinity in mathematics cannot be proved. But both the 0 and infinity are very foundational to our mathematical thinking. We will explain this in detail. So there is fun dimension in mathematics, that infinity, you say that it is there, but you have no idea. It is there, of course, it is there, but you cannot prove it. So similarly, you cannot divide a number with a 0. It is remaining undefined. So the next question is, does mathematics represent a reality? This is a very interesting question. What is reality? That which exists, we call it a reality, or the state of being real, we call it reality. Now our question is, does mathematics represent reality? Look at these pictures or the symbols. One is a square, then circles are there, cubes are there, triangles are there. And you will see that all our mathematical symbols are smooth edged, very smooth. Circle, smooth. Triangle, the edge, I'm talking about the edges. They are smooth, not the corners, the edges. Cylinder, very smooth. Suppose I ask you to draw the picture of the mountain far away there. You will see one of the mountains there. Immediately you will draw 3 triangles, or like this part of triangles you will draw. But you know that cannot represent the real reality. The reality, especially the reality is rough edged. Look at the mountain or the tree. You can just draw it on a blackboard, or even you can just take the photo of this. But on a closer scrutiny, you will see this. The reality is rough. The bark of the tree, the lightning, the mountains, the coastal line. You know, on a closer scrutiny, you will see the rough-edged coastal line. There are so much ups and down there, wavy nature there, so much it is there. Then the trees over there, the cloud, you can just represent them using mathematical geometrical shapes, but it's not. Tsunami tidal waves, or the big hurricane, or the rough-edged shapes of the universe, or the volcanic explosion. All these, you can say that you can draw it, or you can picturize it symbolically, mathematically, you can represent it using geometrical shapes, but reality is not smooth. Reality is really rough-edged. This would also help us to address the roughness of the real experiences in our life. So we have to live with this. It's not always smooth. This is another area that we have to explore. Well, does mathematics represent reality? I repeat the question. The answer is yes, to a certain extent, not fully. Because dots, lines, triangles, circles, etc. are smooth-edged. In reality, all the objects are rough-edged. Even the triangle itself, on a closer scrutiny, microscopic scale, that will be having rough-edged. Roughness will be there. So classical mathematics cannot represent reality totally and exactly as they are. This is the idea. So mathematics represent reality only to a certain extent. So that's why even when we talk about can mathematics talk about God to a certain extent, as an indicator, as a symbol, as a metaphor, this can throw more light into it. That's why we are addressing the concept of reality. This could be the human person, the reality could be the universe, the reality could be God, the reality could be anything that exists. Yeah. So in order to address the roughness of the universe, Benoit Mandelbrot coined the word fractal, and he also introduced the famous fractal geometry. Usually, fractals are traces, tracks, marks, and forms made by chaotic dynamic systems in the universe. I'll explain this. You will see this picture. See, this is a fractal shape. Maybe I'll go one more. You will see this is the best example of a fractal. This is a leaf. But if you see this, all these are reduced scale version. If you just pluck out one particular pattern of the leaf pattern, you will get an exact replica of the whole leaf system. So you will see fractals are geometric shapes that can be separated into parts, each of which is a reduced scale version of the whole. So it is the mathematics of the universe, mathematics of the nature, mathematics of our reality. A mountain, suppose you take a small stone, adding to it, adding further number of stones you add, that becomes a mountain. That's a idea. Likewise, if you take a tree, a small portion of the tree, that's a reduced scale version of the whole tree. This idea. So fractals constitute the universe. When reality is roughed, our original understanding or traditional understanding of one dimension, two dimension, three dimension, they work, but only to a certain extent. If you take into account the fractal shape of the universe, then reality, the dimension will be between 1 and 2, like 1.2, 1.3. Or it could be between 2 and 3, 2.1, 2.2, 2.3. So this challenges our traditional idea of dimension. We are talking about one dimension, two dimension, three dimension. With the theory of relativity, we are able to talk about fourth dimension. But there are dimensions in between. That alone can take into account the fractal shapes, the microscopic roughness. So you cannot use traditional mathematics in order to represent the reality in its fullness. So this smoothness is not the universe. Universe is constituted of roughness and rough-edged shapes. This is the idea. So this is known as the fractal dimension. If you talk about a point that is having 0 dimension, line having 1 dimension, plane will be having 2 dimension, cube will be having 3 dimension, which we are familiarized. But what about dimension between 1 and 2? Dimension between 2 and 3. So if you take a bigger mountain with a lot of landscape, with a lot of hills or ups and downs, that will be having dimensions between 2 and 3. So the fractal dimension depends on the size as well as the linear dimension. They make use of that logarithmic mathematics in order to explain the fractal dimension of a rough-edged shape. My next proposal is that I already said reality is rough-edged. Mathematics can, to a certain extent, they can explain reality as rough-edged. My next proposal is that reality is fuzzy. I know, friends, when you hear about this word fuzzy, something vague, something very uncertain, something not very pleasant for us. Because what's the reason? Because we are always beyond, we are always thinking in terms of binaries. We always look for true or false. We always look for yes or no. We always look for this one. But reality is something that takes us beyond. This is an idea that I'll be sharing with you now. We will have a detailed explanation definitely when we discuss. But in order to highlight the other dimension of reality, I am presenting you the uniqueness of mathematics prior to that. And I mentioned mathematics is most commonly used. And likewise, as most of the philosophers spoke about, mathematics is also having a meta dimension. Imagine the beauty of mathematics is most common use. That means it's common. It is commonness, and the uniqueness of mathematics is also its metaness at the same time. Metaness means the beyond dimension, the meta dimension. The commonness, I mean the common or the general picture is it is most commonly used, which I already explained. It's everywhere. We use mathematics in our day-to-day life, in counting, in planning, in calculating. But the meta dimension is also very important, which most often we sideline or we neglect. Let's take the example of two concepts in mathematics, zero and infinity. And you will see that they have religious ramification and God dimension towards the end. Zero. Suppose I talk to you about zero. Zero in mathematics. Robert Kaplan has written a famous book, Nothing That Is, A Natural History of Zero, where he begins the chapter. If you look at zero, you see nothing. But if you look through it, you see the entire universe. This is the proposal which Kaplan makes. This is a very interesting thing. For us, if you ask zero, what is zero, you will say it is nothing. See, it is empty, you will say. It doesn't have much value. That's what, but Kaplan says you think beyond. From a common parlance, if you get 0%, that is nothing. Or zero doesn't have much value. But if you look at zero, you may see nothing. But if you look through it, you see the entire universe. He's talking about the cosmological dimension of zero. Today, cosmologists are talking about, zero in mathematics as well as zero in cosmology, zero in physics. So we begin with the zero in mathematics. It's a digit and it's a number. It separates the natural number and the positive and the negative numbers. And we use it. And several people say that it's a gift of east to the west. Zero is a gift of Arab countries, gift of India to the west. That's the way it's been. Anyway, there is a mention about zero in Brahmaspida Siddhanta by Brahma Gupta, written in AD 628. So this has been used exponentially and logarithmically in mathematics. So that's a mathematical notation of zero as a digit and as a number. But when it comes to cosmology, as Kaplan said, cosmologists say that the universe had a beginning in a zero, they say. And that zero is known as the cosmological singularity, the cosmic singularity or the cosmological singularity. The laws of physics is unknown. Time is equal to zero. Space is equal to zero. Infinite density, infinite pressure, and infinite temperature. That is a primeval zero. And the universe emerged out of a catastrophic explosion 15 billion years ago. That's a famous Big Bang theory. So it emerged out of a catastrophic explosion of a primordial or primeval zero, they call it. See, this is the idea that the cosmologists are propagating or promoting. So for us, this is the beginning is known as the cosmological singularity or the cosmological zero. So the whole universe from a cosmological perspective, you can interpret emerged out of a universal zero, the primordial zero, the primeval zero, you call it. 15 billion years ago, this zero existed in the cosmic singularity. So the universe emerged out of this. That is from a cosmological perspective. So from this perspective, zero is creative because this has created the universe. And when it comes to physics, you have and we have absolute zero. That is the lowest temperature possible. This is mentioned as minus 273.16 degrees Celsius. And this is the lowest temperature possible. This is again a speculation. Nobody could reach that temperature, but this exists. Absolute zero exists. At least, it exists. Theoretically, it's a possibility. Absolute zero. We have not attained it though. But the lowest temperature possible. And similarly, in the world of physics, you will see, the world of physics, you will see a relativist zero. That is black hole. The relativist zero is black hole. Well, we continue. That relativist zero means the black hole in physics. That you know that when a star dies, this will turn into either neutron stars. Bigger stars means they will form into black holes. This is the idea. Enormous amount of energy is drawn into a black hole. That's why it looks black. This is termed that as a relativist zero in physics. And there is also in the world of microscopic world of quantum mechanics, you will have quantum zero. That is quantum vacuum. This is not just vacuum. Enormous amount of energy can be drawn out of vacuum. There are virtual particles in it. This is the world of quantum mechanics. So you see that mathematical zero, cosmological zero, absolute zero, relativist zero, quantum zero. The zeros rule the world. This is the idea. The zeros rule the world. And when it comes to, when we draw the mystical dimension of zero, you will see that there's no direction, no time, no space. It's imaginary, but very, very powerful. It's mysterious from a cosmological point of view, creative, and it's also life-giving. So you can very well portray the mystical dimension of zero, because if you look at zero, it may not be anything, but if you look through it, you see so many mysteries of the universe. So the mystical dimension of zero and the paradoxical dimension of zero takes us to a realm which is so much, again, mystical. Zero in science or mathematics is approachable, but not attainable. It is there, but you cannot catch it. It is there, you cannot contain it. You can approach, but you cannot attain it. This is imaginary, but very powerful. It is immeasurable, but very, very impactful. It is incomprehensible, but this is very dynamic and life-giving. So zero holds the secret of the origin of universe. And in quantum mechanism, zero holds the secret of energy, that is the 0-point energy, the fullness of emptiness, they call it. It is paradoxical, it is mysterious, it is ambiguous, but still, this is not just an ideal. This is not just an imaginary concept. This is having so much impact in the world of sciences and even in our day-to-day life. Let's just draw the philosophical significance. Shunyata, in a Sanskrit, Shunyata is in a way zero, because Puja, they call it. Zdvi, the root meaning calls swelling. It is developing, it is improving. That is a root meaning of Shunyata. Then Purusha, Shunyata, Svi. And the Buddhists would say, this is thisness, this is thatness, this is suchness. So from a Buddhist perspective, Shunyata is not just simply zero, but it is not just emptiness, it's a fullness out of nothingness. This is an experience of being one with God, Shunyata, the Buddha experience, enlightenment. See, this is taking you to another realm of our experience, Shunyata. It is not the Sanskrit simply just a zero, empty, void. No, definitely no. And in Rig Veda, that is the Hindu scriptures, there you will see Purusha, the primordial being, is sacrificing itself to give rise to the universe and the different entities in the universe. The Rig Veda is talking about the self-sacrifice of the primordial human person. That is God himself. God is emptying himself, the self-emptying of God, self-giving of God, the self-giving of God. That is so much the philosophical and religious significance of nothingness can be brought into in a very meaningful fashion. And Shankaracharya is talking about Indian philosopher, void philosophy. That is also, it's based on the concept Advaita. Advaita, that is not two, but one. It is, everything is one. It is not, and he's also talking about the material reality is illusion, but the eternal reality, that is the real. So we are aspiring for the real from a religious point of view. And from a Christian point of view, the Trinitarian dynamism, Father, Son, and the Holy Spirit, they are united in love. One empties it into the other so that they exist in one. They are one in three and three in one because of this process of zeroization, self-emptying process, or self-giving process, or self-offering process. This is the idea. So that's why Karl Rahner said, zeroization is not an adjective, but God himself. God himself is the notion of God himself is, you can talk about a zero God, or God who is always zeroizing himself so that there is life for us. This is the idea. Though he was in the form of God, did not regard equality with God, emptied himself to the extent of death on a cross. So you can draw metaphorical parallels, drawing these mathematical concepts into the concept of God for a better understanding of reality in the contemporary times. Similarly, if you take the term infinity, definitely you have, what is infinity? If I ask, we would say the greatest of all greats, or the greatest. There is nothing greater than this. This is the idea of infinity, or the longest, or the biggest. See, that's a way we understand infinity. But if I ask a question, what is beyond infinity? Immediately people would say, it is infinity. What is the value of infinity? Again, infinity or infinite. Is there anything more than infinity? That is also infinity. Is infinity real? Yes, it is real. Is infinity imaginary? Yes, it is imaginary. You can, we can ask, questioning the concept of infinity, that will take into different realms. Do they exist? Yes. Do they really exist? We have no idea. Conceptually exist, we say. It is abstract. It's an abstract reality, we say. So they are paradoxical again, like zero, but they are taken to a meta dimension. Remember, I've highlighted these two examples in order to highlight the meta dimension of infinity. Infinity. See, this is very infinity that takes us to a religious God talks. This helps for our God talks. And Anaximander said infinity is limitlessness. Anaxagoras said matter is infinite. Aristotle said actual infinity is not possible, potential infinity. Plotinus said mind is infinite. St. Augustine said incomprehensible for the human mind. So you cannot comprehend it. And for us, all these are correct. All these are correct. Even the finite human person is capable of imagining the infinite. So it is infinite, matter is infinite, finite human person is also in a way infinite. At least he can imagine the possibility of infinity. So potentially infinite, mind is infinite. This different ways. And Emmanuel Levinas would talk about the infinity is in the other, infinity in relationship, infinity of love. And scientists would talk about the infinity of space and the infinity of time, that is eternity. See, like that you can draw parallels and you can explain it or interpret it in different ways. Well, George Cantor, one of the famous mathematicians of the 20th century, he introduced a very interesting concept. And just quickly, since we are running short of time, I'm quickly talking about it. He spoke about infinity. He started talking about finites. Then he spoke about transfinites. Then he introduced infinity. Finites, transfinites. Then he said infinites. Finites, transfinites, infinites. And to this, he made use of set theory. The idea is that, I'm putting it very briefly, the idea is that he said infinity is actually, if you take the whole number system as omega, you add 1 to it, that becomes omega plus 1. Add 2 to it, omega plus 2. But the idea is, he defined each number as a set. The empty set is given the number 1. The set that contains 0 given the number 2. The set that gives number 0 and 1 given the number. See, like that, he has given the number to each set. And each set is considered as, each number is considered as a set. That's the idea. So he made use of this, his genius, to understand, introduce transfinites. And finally, he said the totality of all the infinities is absolute infinity. And for us, we can draw a parallel to this. The totality of all the infinities, he said, that is whether the number infinity or the length infinity or the breadth infinity or the counting infinity, the totality of all the infinities, he called it a set that contains all sets. And for us, that is absolute infinity. And Thomas Aquinas would easily connect absolute infinity to God. And actually, as mathematicians who are having faith, we can definitely connect this, the concept of set theory and the concept of cardinality and ordinality, which he speaks in terms of sequentiality and the number positioning. And he made use of this technique to introduced the idea of finites, transfinites, and infinites. And all together, he said this is the totality of infinity, and he called it absolute infinity. Absolute infinity for us that evokes our idea of God in a different way, the totality of all infinity from a mathematical point of view. So this is explanation of the same. So again, infinity as a symbol, infinity as a meta-dimension level, infinity as an imaginary concept. It cannot be proved, but cannot deny the existence. God cannot be proved, but cannot deny the existence of God. Similarly, infinity, you cannot prove, but you cannot simply deny the existence of God. So it evokes our understanding of God in a different way as the totality of all the infinities. And Hindus, well, I represent India, and this is one of the dominant religions in India. And they have the wonderful Brihadaranyaka Upanishad scriptures where they talk, Om Purnamada Purnamidam, Purnat Purnamudachyade, Purnasya Purnamadaya, Purnamevavashishyate. This is Sanskrit. Meaning is this is absolute, that is absolute. If absolute is taken away from absolute, absolute remains. This is the idea. So how is this possible? This is beyond our ordinary understanding of mathematics. This is not arithmetic thinking. This is beyond binary thinking. So I'll be taking next a few minutes to introduce the final concepts of my presentation, beyond binary thinking. To this, I will be making use of a mathematical concept called fuzzy logic. After sharing this with for next a few minutes, I will conclude that we can have our discussion. So dear friends, beyond binary thinking. What do I mean by that? There is a logic called, or mathematics called fuzzy logic, and a mathematics called fuzzy mathematics. A logic called fuzzy logic, and a mathematics called fuzzy mathematics. Fuzzy mathematics is based on fuzzy logic. That's a connection. Traditionally, we say there is true or false, yes or no, you are right or I am wrong. This is the binary thinking that dominates our understanding or thought pattern or linguistic paradigms. Binary. We always look for answers. But very often, the intermediary truths are not taken into account. What is in between truth and false? What is between true or false? What is between tall or small? Tall or small? What is between bright or average? See, there are people in between. Fuzzy logic takes into account this category. This is the idea. This is a very interesting mathematics, and this is so much connected with our idea of God. I will explain. Traditional philosophy and classical mathematics divided the world into realities of world into two, yes or no, or true or false paradigm. There is no possibility of being in between. Rich and poor, majority and minority, powerful and powerless, strong and weak, these are binary thinking. Whereas traditional thinking pattern is mostly binary. Suppose I ask, who are the tall persons in this class? Immediately we will attribute and define a scale. Those who are having 6 foot tall, those who are having less than 6 foot short. And we have only 2 categories. Those who are 5 foot 11 inches will be put under the category short. Those who are 5'10", 5'11", they will be put under the category short. Likewise, those who are 6.5, even 7 foot height, they have only one category, tall. So there are only 2 categories, but reality is of different layers. We do not take them into account. Suppose I ask you the set of people who are aged 20. Immediately, those who are aged 20 will raise their hand. Suppose I ask you those who are aged around 20. Immediately, 21 will raise their hand, 22 will raise their hand, 23 will raise their hand, 19 will raise their hand. See, they are around 20. I've been talking about, see, fuzzy logic. I'll explain it. I have got an apple in my hand. It is not an apple, but I've got an apple in my hand. I bite the apple. One bite I ask, what is in my hand? You will say, well, that's apple. Second bite, what is in my hand? Apple. Third bite, what is in my hand? I would say, again apple. But fifth bite or sixth bite, if somebody is good at eating, seventh bite, you will finish the apple, then there is no apple. See, from apple to non-apple, there is a gradation. With each bite, appleness decreases. Traditional understanding, there is only two categories, apple and non-apple. But fuzzy logically, fuzzy mathematically speaking, there is apple, appleness decreases, 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 decreases. There is a grade of values. This is the idea. I'll explain again. You have already understood, I'm sure. So this is the idea that in traditional understanding, categorical crisp values are taken. 1, 2, 3. But in fuzzy logic, degrees of truth are taken. Fuzzy logic, there is absolute truth and absolute false as the boundary. In between, there are somewhat true, more or less true, almost true, like that various layers are there. This is I wanted to explain it in detail, union of a set, which we have learned in our high schools, intersection of a set. This is the complement of a set. But when it comes to fuzzy mathematics, there is a difference. You see, in classical set function, there is only tall and not tall, two values. But when it comes to fuzzy mathematics, you have not tall, almost tall, somewhat tall, very tall, more or less tall, short. All these values are there. Tall and short and very tall and very small are also there. The intermediary values are taken into account. The layers are taken into account. This speaks about fuzzy logic. Fuzzy sets are not precise. Membership is not a matter of degree. This is the idea. So now you see there is something called a fuzzy number. 1 plus 1 is, or 2 plus 3 is always 5. But in fuzzy mathematics, 2 plus 3 can be more. I'll explain how. 7, I have given fuzzy number 7. 6 participates in 7, 5 participates in 7. 8 participates in 7, 9 participates in 7. But their grade of participation varies. 7 participates in 8, 7 participates in 9. 7 participates in 6, 7 participates in 5. But their grade of participation, you can give values, 0.4%, 0.5%, 0.8%. When it comes to 7, it is 100% or 10%. See, the fuzzy number is like a triangle. This is not a crisp value. It's like a triangle. It participates in the other. That's why 2 plus 3 can be 5. 2 plus 3 can be 5.5. 2 plus 3 can be 6. 2 plus 3 can also be 7. 2 plus 3 can also be less than 5. This is the brilliance. He made use of the complementarity law in fuzzy logic. It's like a point-like number, but in fuzzy logic it is triangular number or trapezoid number. The shapes varies depending on the context. So my idea is that in binary thinking, we use binary language, but in fuzzy thinking, we use multivalence. Either it's not either or, it is both and. It is in binary, it is crisp, but in fuzzy, it is paradoxical. Binary, it is bytes or bits, but in fuzzy, it is fits. It fits. We are fitting to the context. Reality is comprehensively taken into account. It no way disregard the binaries. It includes binary also. At the same time, it takes into account the intermediary values. That's the idea. And a very interesting theorem. This I can apply this into the Trinity. Usually we say whole can be contained in the part and part can be contained in the whole. This is the idea. Usually we say the part is contained in the whole. But in fuzzy logic, you can say whole is also contained in the part. Part is also contained in the whole. Whole remains whole and part remains part. This is fuzzy substitute theorem. It is different from traditional classical logic and other fuzzy substitute theorems. This is a different word because here the law of complementarity is different. When we engage in conversation, I can explain. So the whole can, like that, you can say that 1 in 3 and 3 in 1. You can say 1 and 2 and 3 or 1, 1, 1, Father, Son, and the Holy Spirit. They remain unique, but they can be distinct, but you cannot separate them. This is the idea of fuzzy logic. There can be one, at the same time there can be three. I mean, ontologically, definitely there are problems, but more than the philosophical explanation of 1 in 3 or 3 in 1, this can give you a theoretical possibility of a 3 in 1 and 1 in 3. This is the idea I wanted to highlight mathematically. Use ordinary mathematics, A union A complement is the full set, A intersection A complement is null set. But in fuzzy logic, it is not. That's the brilliance. He made use of this complementarity law in order to explain fuzzy substituted theorem and other concepts. And putting it in a nutshell, reality is fuzzy. You take matter, you can touch atom, you can understand Higgs boson, difficult. Rain, you can predict. Storm, less prediction. Tsunami, tidal waves, very less. See, natural events from this side to that side, it becomes fuzzier. Persons, you can touch. Friendship, you cannot. Love, very vague. Scriptures, you can touch. Traditions, you can so much understand because of the fathers of church. But God and religion is fuzzy in nature. Don't take literally. Fuzzy means vague as far as the concept is concerned from a common point of view. So reality is actually, put it in a paradigm, it is fuzzy. You have the binary stuffs there, you have the intermediary stuffs there, you have the fuzzy stuff there. Reality is fuzzy. Take God, rain, or friendship, or scripture, or divinity, or doctrines, or conflict. You can put everything together. But there is an increasing amorphicity, there is a decreasing amorphicity. There is an increasing knowledge, there is a decreasing knowledge. So reality is fuzzy. This is my idea. Can you apply this into the God language or fuzzy language for God and religions? This is my idea. Trinity in Christianity, always I explained. You can explain 3 in 1 and 1 in 3 with the fuzzy logic. Shunyata in Buddhism. Shunyata, it is not binary concept. This is beyond binary. That is a fuzzy idea. Beware, this is not a vague idea. I mean, the idea is vague, but don't treat the word as it is. Aham Brahmasmi. This is Sanskrit. I am Brahman. That's a beyond the binary thinking, beyond the personhood you have to think. Tattvamasi, that you are. You are the Brahman. This is a unique understanding that you become one with God. That is fuzzy language. Most of our religious languages are fuzzy, but meaningful, impactful. This is the idea that I wanted to share. And this is fuzzy thinking in religion, definitely. Very many religions and religious harmony you can connect. And there are fuzzy religions like Jainism, that which speaks about Anegandavada, the principle of plurality. There are also fuzzy persons. Mahatma Gandhi, who was a hardcore Hindu, but he was open to Quran, he was open to Christian Bible, but 100% he was Hindu. He was binary in his faith, but at the same time he was also open to other traditions. This is the idea. That's why I said fuzzy persons. And that way Jesus is also fuzzy Jesus. I mean, if you understand it properly, otherwise problem. You understand it, the binary is there, rootedness and identity, no compromise, but you can be open. This is the worldview that I wanted to share with you. So that way, our idea of God is definitely, it is beyond binary. And still, that's why I say that it is incomplete. Why? With the famous theorem, Gödel's incompleteness theorem, I will stop. Applying this to God, applying this to life, you will see that life is incomplete and the understanding of God is also incomplete. Kurt Gödel in 1931 published this. He said, an axiomatic formalized consistent system can never be complete. The idea is that consistency and completeness never go together. This is the idea. So you apply it to any system, even any system. In science system, if you want to prove the truthiness of a sentence, you have to go out of the system. If you want to prove the truthiness of a statement, it has to go out of the system. Even in artificial intelligence, that's why they find it difficult to artificially simulate the brain exactly as that of the human person. At least human person can understand that you cannot prove the truthiness, even though the sentence is true, but machines cannot. This is the idea. So that's why the humans can understand the uniqueness of the human person, how we are created by God. And this, if you treat God as a system, I mean, definitely you cannot treat God as a system. But even you treat as a mathematical system, that system you cannot prove that will be beyond our understanding. That again reaffirming our understanding of God. So life is incomplete and life has to be incomplete. That incompleteness will give us an inspiration to the beyond. This is the idea that I want to share with you today. So to put it into conclusion, I said reality is rough, reality is also fuzzy, and reality is incomplete, and our understanding of God is also incomplete. With this, I think to see, we know certain things and we don't know very many things. Unknown and the unknown are there. The picture is incomplete and it remains incomplete. As long as it is incomplete, that incompleteness becomes an inspiration for us to imagine or reunite with the complete. And until then, we are marching. And I made use of mathematics not as mathematically perfectly and as fully mathematically, but metaphorically, because the methodologically there are difficulties when you draw parallels to two different realms. That methodological difference we have to understand, but at the same time, this can be used as an effective tool in the contemporary times to explain the theological mysteries. Like we made use of philosophy, we can use it. Now I stop my presentation. You are welcome. The floor is open for a discussion. Any question, anybody? Okay. Any clarification? We can have some time for our conversations.
But this is an issue that has come up repeatedly, kind of the classical theological definition of revelation is that in Christ we have the fullness of the truth. And how do you explain having the fullness of the truth with the human experience that everything that is really true is fuzzy and so forth? So how do you bring those two things together?
Yeah. I think, Robert, that's a great question. First of all, there is a danger in reducing everything into the realm of fuzzy language. No. Fuzzy logic is helpful wherever things are uncertain, things are not known from a mathematical point of view. And if you reduce the faith concepts into the world of fuzzy as such, always, that may not provide us much. We will fall into the pre of reductionism. That's not the word fuzzy is some of our understanding, the faith understandings like revelation, faith, all these are faith realities. You cannot say that mathematically I can reduce this. It's like mathematically I can comprehend God. No, definitely no. These two things are different. A faith language and a mathematical language are definitely different. For a faith person, for us, scripture, tradition, and magisterium are binary values in our faith. Clear? These are binary values. There is no question of bringing fuzzy into a binary thinking. That's our fundamental faith. You cannot compromise. But from perspective of worldview, I said Jesus is fuzzy from the point of view is he was 100% son of man, son of God. He was 100% binary in his understanding and realization. He is 100%. He is, a true God and true man. Well, that's fine. But at the same time, he was able to appreciate and embrace the Samaritan and the Gentiles out of the binary frames those existed in those times. That's why I called him a fuzzy. Unnecessarily, we cannot bring in, and there is no need of bringing fuzziness into any faith languages. But 1 in 3 and 3 in 1, we can, if fuzzy logic is helpful, you can use it as a symbol or as a model. No model is complete. And we cannot reduce everything into fuzzy because fuzzy logic itself is experiencing incompleteness and limitedness. As any linguistic paradigms, any language, any science, any discipline, fuzziness also has got limitedness. The fact that they are taking the truth values into 0,1, the fact that they are making use of adjectives in consonance with the context, these are all problematic concepts. So these are only models. What I said is, more than traditional, some of the traditional philosophical understanding, certain theological mysteries can be explained using fuzzy language or fuzzy logical language. That fuzzy is not vague. That fuzzy is a concise, crystal clear mathematical to address vagueness. That's where we have to take it. So that alone, Robert, I can respond to it. Otherwise, bringing a God concept directly into a fuzzy concept will be creating a lot of problems for us. And even when I talk about fuzzy, binary is a condition for fuzzy. And when we draw this a parallel to the faith language, our faith, scripture, tradition, and magisterium, no compromise. That is not fuzzy. I am not saying that that's not fuzzy. If at all I say that is fuzzy, binary is a condition. So that is already, that is inside fuzziness. That doesn't mean it is vague. It is clear and crystal clear. It is crisp, less crispiness, more crispiness, vagueness. That's the reality I portrayed. Our understanding of God is fuzzy, but God himself is binary. I mean, absolute, no compromise. This is what I wanted to say. Yeah. I think at least I'm giving, I know that this is a paradoxical language I used it, but treat only as a model and only as a symbol, Robert. Thank you.
Father, I have a question.
Please, Christopher.
Father, you mentioned that mathematics doesn't represent the whole reality, but it helps to understand the structure of the reality.
Mathematics, and first of all, Christopher, our question, what is the reality? And when I mentioned about the material reality like mountains, the volcanic explosion, the bark of the tree, or the lightning, the cloud, the coastal belt, to a certain extent, they can represent reality geometrically or pictorially. But on a closer scrutiny, microscopic world, even the astronomical world, suppose I ask you to draw, immediately we'll draw the sky and a few stars and all those things. But the star itself is a nuclear bomb. Enormous amount of 4 hydrogen atoms joined together to form a helium atom. That's the thermonuclear reaction taking place in the star. But for us, the star is something very soothing, very, very bright and light and smooth from far. But reality, in essence, is chaos. This is what I wanted to say. And such a chaotic systems, mathematically, traditional mathematics may not be so much useful. With quantum mathematics or quantum probability theories and so on, to a certain extent, we are able to picture the reality, but still we find it difficult. Even the human brain, to a certain extent, we are able to simulate, but 86 billion neurons and more than 100 trillion neural networks, we are not able to, as of now, represent it even using mathematical algorithms in artificial intelligence. That's why I said, from that view, going into the deeper dimensions of reality, we will find it difficult. Even mathematics, we will find it extremely difficult to represent reality as it is. So we represent reality or imitate reality, or to a certain extent, you can simulate reality, but not as it is. But definitely, the structure of reality can be brought to light. And some of the mathematical models have helped us in history to understand the model of the universe, the standard model of the universe, the Big Bang model of the universe. All these were mathematical models. So they help us, but still there is a long way. We understand the universe only 4.5%. The rest is unknown. The picture is incomplete. This is what I said. In no way disregard the quality of mathematics. It's definitely it is regarded as the queen of mathematics. But there are certain questions which we can raise from the realm of mathematics, which mathematics cannot answer. Because that's what Gödel's incompleteness theorem. You cannot prove the truthiness of a true statement within a system. In order to prove it, you have to go out of the system. So mathematics itself is experiencing a sense of incompleteness from a logical point of view. This is the idea I want to say. But I'm not telling that mathematics cannot represent, but my answer is that to a certain extent, not fully. This is the idea I wanted to communicate with you, Christian. Well, as far as I understand, maybe I can say that it is the concept of George Condor. Based on his set theory, he mentioned about finites, that we are finites. And yeah, he also talked about infinites, and he also talks about transfinites. That's a mathematical conjecture. In reality, we will find it difficult because he treated the whole, each number, natural number, as a set. The empty set is given the number 0. The set which contains 0 is given the number 1. The set which contains 0, 1 is given the number 2. Like that, the number of sets increases, and the whole natural number is taken as a whole set, omega. Then he said the reality is like omega less than omega plus 1, less than omega plus 2, continues omega to the power of omega. So like that, these are transfinites for him. This is a speculative idea. Finites, transfinites, that is between infinity and finites, then very many infinites. And the totality of all infinites is known as absolute infinity. And I said, he did not say, I said that can be treated as, or I mean, you can draw a parallel to this, to our concept of absolute infinity, which Thomas Aquinas mentions about God with all properties and everything. This is what I wanted to say. But how he come to this proof? Idea is he is using the idea of sequence in mathematics in set theory. There is an ordinality number for that. And he's also using the idea of positioning the number system that is known as cardinality. He made use of ordinality and cardinality to explain each finites and transfinites. Then he took a totality of all this into to understand the total infinity. And for us, this easily vibrates with or resonates with our understanding of an infinite God, the totality of all infinity. There is nothing greater than this. This is the idea I wanted to share, Father Sika. Any other question? Otherwise, okay. You may also feel free to contact me via email. I have got my email. I'll share with you my email ID. In case you have further questions, now definitely you can have these questions even in person via email. You are most welcome. Thank you, dear friends. Thank you for your patient listening, and that is appreciated.